What's up, everybody? This time we're doing quadratic key features from a graph. So this is online lesson number 9. Alright, so go ahead and hit pause so you can read these definitions. Um, Go ahead and hit pause. The one I do want to talk about, though, is x-intercepts. So that is the point where it crosses the x-axis. But just be mindful that x-intercepts have multiple definitions or multiple words for it. So we could refer to the x-intercepts as zeros, roots, and if the quadratic function is equal to 0, the x-intercepts will also serve as the solutions. So if it's asking for x-intercepts, zeros, roots, and solutions, these all mean the same thing, or can be used interchangeable to a certain point. Alright, when it comes to x-intercepts, there's 3 possible options. You can have 2 x-intercepts, like in the first example. You can have one x-intercept where it just touches the x-axis, and you can have no x-intercept, so the parabola itself misses the x-axis completely. Alright, so the first thing we're going to do for this problem is we're going to find the vertex of the problem. So this is right here the parabola. So just remember the U-shaped graph is called a parabola. So we're looking for the vertex of this parabola. Now that's where it changes direction, so it's either going to be the highest or the lowest point, which is known as a maximum or minimum. So here we have a lowest point, which is a minimum. So the vertex is that coordinate, so it's -1, -4. Now we're going to look for the axis of symmetry. That's where the parabola is divided in half. So look for the middle of the parabola, which is also the vertex, and draw a vertical line going through it. Alright, now that I got my vertical line through it, you notice that it goes through -1 on the x. So that means our axis of symmetry is x equals -1. Now the next thing I'm going to look for is maximum or minimum value. So just be mindful, if it's a maximum, it is concave down. If it's a minimum, it's concave up. And so we look for the lowest y value or the greatest y value here. Since we have a minimum, that means the parabola does not get any lower than this y value at y equals -4. So we have a minimum, min for short, at y equals -4. Now we're going to look for the x-intercepts. So if you notice, this one crosses twice. So we have an x-intercept right there, which is 1, 0. We have another one over here at -3, 0. Now lastly, we're going to look for the y-intercept, which happens to be right there. So I'm going to write it off over here. That is 0, -3. Now I'm just going to go in and fill in all my blanks now that I have my graph annotated. So the vertex is -1, -4. Axis of symmetry is x equals -1. We have a minimum at y equals -4. Our x-intercepts are 1, 0, -3, 0, and our y-intercept is 0, -3. Alright, here's another example. This time we're doing a parabola that is concave down. So just remember, the U shape is a parabola. Now starting off with the vertex, this is where it changes direction. It goes from increasing to decreasing. And that coordinate is 3, 4. Next thing I'm going to look for is the axis of symmetry. So now that I know where my vertex is, I'm going to draw a vertical line going straight down it. And so if I notice, it goes through 3 on the x-axis, so my axis of symmetry is x equals 3. Now I'm going to look for my maximum or minimum value. So since I know that this is my highest point of my parabola, that means I have a maximum. So max at y equals 4. Now I'm going to look for my x-intercepts, which happen to be right there and right there. So my x-intercepts are 1, 0, and then the other one is 5, 0. And the last thing I need to look for is y-intercept. So if I look closely, that's where my y-intercept is, which happens to be 0, -5. Now I could go back and fill in all my blanks. So the vertex is 3, 4. Axis of symmetry is x equals 3, and again, it's always x equals. And then for maximum or minimum value, so remember, concave down, maximum, concave up, minimum. And we said we have a maximum at y equals 4. Now the x-intercept is 1, 0, 5, 0. The y-intercept is 0, -5. So this time we have a parabola down here. So again, remember the U shape is called a parabola. Starting off with the vertex, our vertex happens to be right there. So vertex is 2, -4. Now it's always important to pay attention to the scaling. So it's the units are going by 2's, but there's a line in between them, so the increment is still going 1, 2, 3, 4. So the vertex is 2, -4. Now I'm gonna draw my vertical line going through the vertex for my axis of symmetry. So it looks like my axis of symmetry is x equals 2. Now I'm going to look to see if I have a maximum or minimum. So remember, maximum is concave down, minimum is concave up, and it'll look at my parabola that is concave down. So that means that I have a maximum at y equals -4. Now this one's interesting because I'm looking for my x-intercepts. Here's my x-axis. Does this parabola intersect the x-axis whatsoever? Well, it doesn't. So anytime you encounter one where it doesn't have x-intercepts, you're going to write no solution, or you could write NA for not applicable, or you could write no x-intercepts are found. And so lastly, we're going to look at the y-intercept. So this one is not perfectly on the grid, so you're going to have to estimate it some. So whatever you approximate that is, that's between -5 and -6. So I would say that looks like 0, comma, -5.4. Now I'm going to go back and fill in my blanks. 2, comma, -4, x equals 2. We have a maximum at y equals -4. The y-intercept is 0, comma, -5.4. And just be mindful that if there are no x-intercepts, you will write no solution. Alright, go ahead and hit pause so you can work out these problems yourself. Go ahead and hit pause so you can work out these problems yourself. Go ahead and hit pause so you can work out this problem yourself. Again, go ahead and hit pause so you can work out this problem yourself. Alright guys, thank you for watching. I hope you have a good day. Again, thank you for watching.